Welcome all of you dear students. We are celebrating most popular Vijayadashmi festival in all over India. We have already learned the basic properties of light, that is reflection and refraction. My humble request to all of you that be reflect sometimes and be refract sometimes according to the different conditions and situations. I express my views to the bottom of my heart that may this Vijayadashmi festival brings you lot of happiness and brightness as well as lots of light in your life. So this is the simplest and easiest way of teaching learning process in our most popular YouTube channel. Physics Make It Simple by Dr.Rajendra, now serving as a principal in Lokanete Dr. Balasaheb Vikhe Patil, Padma Bhushan Awardee, Mahatma Phule Vidyalaya and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. As long as 12 Science Wave Optics is concerned, this is the lecture number 7, and in this lecture we are going to discuss most funny article, that is dependence of wavelength on refractive index of the medium, or best way we can say that what is the effect of refractive index of the medium over wavelength of light. This is our first question. I will repeat this question again. What is the effect of refractive index of medium over the wavelength of light, or how the wavelength depends on refractive index of the medium? This is our first question. The second question that we are going to discuss here, that is dependence of frequency of light on the refractive index of medium, or we can make a question like this: what is the effect of refractive index of the medium over the frequency of light? Okay, these two questions we are going to discuss in this lecture. For that purpose, I have drawn two diagrams on the board. Observe that two diagrams at first. The first diagram is what? Plane wavefronts incident normally on the boundary XY between rarer medium and denser medium. XY is the boundary which separates two media, rarer medium and denser medium. This is the first thing. In the first figure, ray of light is incident normally. That means that ray of light incident perpendicular to the boundary XY. Remember well dear students, when the light is incident normally, that means along the normal, such a light cannot bend at the time of refraction. Most important property. When ray of light passing along the normal, or ray of light incident normally at that time, during refraction light does not bend. So light is moving in straight line direction. I have drawn three plane wavefronts. That plane wavefronts A, B, C, D, E, F, that three plane wavefronts are equidistant. Distance between two successive plane wavefront is lambda 1. That is the wavelength of light in rarer medium having velocity v1, and we already know plane wavefront is formed when the source is at infinity. Such a plane wavefront gradually incident on the boundary, and during reflection it moves into the denser medium. When it moves into the denser medium, at that time velocity of light goes on decreasing because the medium is denser. That velocity is v2. That all things I have written in the labeling. I will read here. v1, velocity of light in rarer medium. v2, velocity of light in denser medium. Lambda 1, wavelength of light in rarer medium. Lambda 2, wavelength of light in denser medium. N1, frequency of light in rarer medium. N2, frequency of light in denser medium. Mu1, refractive index of rarer medium, and mu2, refractive index of denser medium. That all things I have already written in the labeling. So what is the description that we want to write as long as examination point of view? In the diagram, incident rays P and Q are incident along the normal, and when they are incident along the normal, they cannot bend, they move in a straight line direction after refraction. This is the first thing. Three plane equidistant wavefronts are shown as shown in the figure. A, B, C, D, E, F. These are the three plane wavefronts which are equidistant, and distance between two neighboring plane wavefront is lambda 1, which is nothing but the wavelength of light in rarer medium. After refraction, distance goes on decreasing because velocity in the denser medium decreases. So distance decreases. Here distance is larger. But when it comes into the denser medium, distance between two neighboring plane wavefront decreases. And distance between two neighboring plane wavefronts during refraction is lambda 2. The same description we can write when the ray of light incident obliquely. What is meant by obliquely? Obliquely means the ray of light incident on the boundary between two media, making a certain angle I. Here is no I. Incident angle is 0 here, because the ray of light is incident normally, which are incident along the normal lines, but here they are incident obliquely. Here also the procedure is same. Distance between two neighboring plane wavefronts is lambda 1. Sorry, here we should write lambda 1. Lambda 1. Distance between two successive plane wavefront is lambda 2. Here distance decreases after refraction. After refraction, it changes its direction. Here the direction is not changing. It moves in straight line direction because they are incident normally. Here these are the refracted angle R. So these all things are same. So what is the calculation here? We know velocity of light in rarer medium V1 is equal to lambda 1 upon capital T. What is capital T? The plane wavefront moves from this point to this point, this point to this point, this point to this point in a particular time capital T. Or we know when the wave covers a distance equal to lambda, at that time required to cover a distance equal to lambda is capital T. I will repeat again. Time required to cover a distance lambda is capital T, which is nothing but periodic time. So here distance upon time is the velocity. V1 is equal to lambda 1 upon capital T. This is the formula. We will write here equation number 1 in rarer medium. In rarer medium. So after refraction, what happens? I will write here. After refraction, velocity becomes V2, which is equal to lambda 2 upon capital T. The time remains same. For the same time, it covers a distance equal to lambda 2 having velocity V2. This is equation 2. Then comparing equation 1 and 2, we get what? V1 upon V2 is equal to lambda 1 upon lambda 2. This capital T and capital T gets cancelled. And this is the equation number 3. Okay. Then we know V1 upon V2 is equal to lambda 1 upon lambda 2. This is nothing but the velocity ratio or wavelength ratio is nothing but what? Is nothing but refractive index of second medium with respect to first, which is equal to mu 2 upon mu 1, like this. So from this we can write what? What is lambda 2? I will take lambda 2 here. So lambda 2 is equal to, I will only write like this, lambda 1 upon lambda 2 is equal to mu 2 upon mu 1. Mu 2 is the refractive index of denser medium. Mu 1 is the refractive index of rarer medium. I have omitted this part and only we will build up the relation between wavelength and refractive index. So lambda 1 upon lambda 2 is equal to mu 2 upon mu 1. And from that we can write like this. Lambda 2 take one side. We will get what? Lambda 2 here. We will get what? Lambda 1 into mu 1 upon mu 2, like this. Mu 1 upon mu 2. Let us observe this. Here mu 2 is the refractive index of denser medium. Mu 1 is the refractive index of rarer medium. Remember well, refractive index of denser medium is always greater than refractive index of rarer medium. Or we can write refractive index of denser medium always greater than 1. Mu 2, since mu 2 is greater than 1, when mu 2 is greater than 1, then this ratio is less than 1. This ratio is less than 1. So lambda 1 into less than 1, this factor comes lesser, and from this we can write lambda 2 is less than lambda 1. So wavelength of light in denser medium is less than wavelength of light in rarer medium. Wavelength of light in denser medium is less than wavelength of light in rarer medium. This is the answer of first question. what is the effect of refractive index of medium over the wavelength of light. So take a screenshot for the answer of the first question. Take a screenshot. Take a screenshot. Okay. So after learning this, we are going to learn now dependence of frequency of light. Frequency of light, we have denoted it by small n1 and small n2. Small n1 is the frequency of light in rarer medium and small n2 is the frequency of light in denser medium. So what is the relation between frequency of rarer and denser, or what is the effect of refractive index of the medium over the frequency of light? Okay, see here. Here we know V1 upon V2 is equal to lambda 1 upon lambda 2 is equal to mu 2 upon mu 1. Or we can write only this. V1 upon V2 is equal to lambda 1 upon lambda 2. So what is V1? V1 is equal to N1 lambda 1. What is V2? V2 is equal to N2 lambda 2. N1 is the frequency of light in rarer medium and lambda 1 is the wavelength of light in rarer medium. N2 is the frequency of light in denser medium and lambda 2 is the wavelength of light in denser medium. V1 is the velocity of light in rarer medium. V2 is the velocity of light in denser medium. Okay, we will put here, we can get what? V1, N1 lambda 1, V2, N2 lambda 2 is equal to lambda 1 upon lambda 2. Here lambda 1 upon lambda 2 and lambda 1 upon lambda 2 get cancelled and you will get what here? N1 upon N2 is equal to 1, or we can write here N1 is equal to N2. What this equation indicates? Frequency of light in rarer medium is equal to frequency of light in denser medium. It clearly indicates that there is no any effect of refractive index of medium over the frequency of light. Frequency of light remains constant when it moves from rarer medium to denser medium, though refractive indices of rarer medium and denser medium are different. We know refractive index of rarer medium mu 1 is less than refractive index of denser medium mu 2. Though this condition is there, but there is no effect over the frequency of light in rarer medium as well as denser medium, or in short we can say that during refraction frequency of light remain constant. So this is the effect of refractive index over the frequency. We have already learned, earlierly we have learned effect of refractive index over the wavelength, and that effect we get here. Wavelength of light lambda 2 in denser medium is less than wavelength of light in rarer medium. How this proved? Because mu 2 is always greater than 1. So this ratio is less than 1. And if this ratio is less than 1, suppose here 0.9 into lambda 1. Lambda 2 is obviously less than lambda 1. Lambda 2 is obviously less than lambda 1. So there is a effect over wavelength, but frequency of light remain constant. So this is all about dependence of wavelength as well as frequency on the refractive index of the medium. Remain alert to my channel always, and we are going to approach another interesting article in wave optics, that is, what is polarization, what are the concept of polarization, what are the properties of polarization, what is diffraction. Such a funny and interesting article that we are going to learn in the next few lessons. So remain in contact to my channel. My humble request to all of you that to enhance my energy, please subscribe my channel. Goodbye.